Hi everyone, welcome back. Naji here. In this video, we will be discussing or we will be understanding how can we do the context engineering for deep agents. So most people think that building agents is only selecting a model or connecting the tools. But in real project, the biggest challenge is actually the context management. There are a lot of questions like what all information a agent should remember, and what should stay temporary, and how to avoid the context overflow, and how to do the sub-agent. And there are a lot of questions are there. There are another question usually happening is that how to keep uh, the memory for the long conversations. Okay, so in this video we will try to understand these. I will try to answer these questions, and hopefully like we will get a good understanding of the context engineering. Okay, so how to execute a task, or how can we ensure that, or what all things an agent need to execute a task? It need the right information, it need right tools, and it should be in a right format. Okay, so if we can provide this information to an agent, then it will able to work in the expected manner. Okay, so most of the beginners may think that okay, selecting GPT-5 or the Gemini Pro, okay, that will automatically will work. No, that is the wrong thing. Okay, so even the best model will definitely will fail if the context is wrong, or if the memory is overhead, and if the tools are unclear, or runtime information is missing. So if these things are like not properly given, then even the best models also will fail. Okay, so in a deep agent, so we can categorize the context, or the agent will get the context in a like a 4 different ways. We can categorize into 4 different ways. One is the input context. Okay, so the input context will includes, we can discuss in later slides, we can discuss in very detailed way. So the input context contain the system prompt, memory file, and skills and the instructions. And the runtime context, from the name itself, it is very clear, like very clear, right? Like because the agent will get the context in a runtime. So it should be like a user ID, API key, permissions, etc. Then the context compression. So in a long conversation, right? So we may be offloading the context into a file, or maybe we summarize the details. So these also we will pass into the agent, and we will have like a context isolation. So the context isolation is actually we discuss in terms of the sub-agents. Okay, for example, I am assigning, or I am giving a task to a sub-agent, and sub-agent will execute that, and it will return the result back to the agent. So that is also considered as a context for the agent to execute. So coming to the input context. Okay, so in our last slide we discussed about the different context that the agent will get, and here we discussed about the input context. So input context is the one of the context that we pass to the agent. Okay, so input context we can in a top level we can classify it into the 4. One is the system prompt, and second one is memory, third one is skills, and the fourth one is the tool prompt. The system prompt, like it is very clear, right? It defines some role, behavior, or the functional knowledge. So that is the system prompt. And the tool prompt, these are the instructions that we are giving to the tools, or we are getting from the tools, that we can categorize in the tool prompt. Then there are the 2 other things, that is the memory and the skills. Okay, so this is if you are this will not be seen in our normal agentic application. This will come into the deep agents. Okay, so memory, which means that okay, persistent guidelines and the preference loaded via agents.md. Okay, so agents.md, right? So you guys have seen, or you guys have written like readme.md, right? So what is the readme.md contains? So readme.md contains kind of an instruction for the humans or the developers, like how to execute something, or how to some information. Like this usually be added with the GitHub repo or the Bitbucket repo, right? So it says about okay, what the project contains, or how to install the requirements, all those things it contains, right? So similar to that, agent.md is some kind of a guidelines for the agents how to execute something, or how to understand something. So those kind of details will be there in the agents.md. Okay, now another is the skills. Okay, so what is mean by a skill? specialized workflows and the capabilities loaded on demand. So that is the importance of this. It's loaded in the on demand. For example, I have a skill set, consider skill set.md and something like that is there, which contains how to read from a S3 file location. Okay. So whenever the deep agents start working and all those things, what it does is it will just read the summary or the front line of the skills.md and it will understand that okay, there is some instructions is there how to read from S3 bucket. Okay, that's it. It will not load entire skills information. So whenever a requirement comes, like the agent has to read from the S3 location, then it will check that okay, I have a skill set saying that how to read from S3, then it will load this specific skill set, then it will execute the task. So which means it is dynamic, it will not load everything at the initial stage. The skills will be loaded only as the need basis. Okay. Now here I just want to specifically say like what is the difference between the memory and the skills. As I said, memory is specifically kind of a hard-coded one and it is loaded with the system prompt at the initial stage itself. But skills are different, it is loaded only in the on demand. Okay, so I hope that is clear. Now let's understand about the entire system prompt. So if you look on this, if you entire system prompt contain the custom system prompt, base agent prompt, to-do list prompt, memory prompt, skills prompt, virtual file system prompt, sub-agent prompts and custom middleware prompt and the humans in the loop prompt. So all those still contains finally forms the entire prompt to a model. Okay, now let's understand the context, runtime context execution. Okay, so in this, which means like in the runtime we will be providing like some information, some dynamic information for the agents, like the current user, API token, account information, maybe database connection, etc. We will be giving in a runtime context. Now understand about the context bloat, right? So if the conversation grows, actually the message is increasing, the tool output is increasing, then the summaries also increase, right? And the file detail, the offloading file is also will increase. So eventually, if the context is like full, it will cost like a increase in the cost, and it will increase the latency and it will increase the hallucination, right? So in our coming slides we will understand how to reduce the context bloat in deep agents. Okay. So one of the method that we use the compression of the the context compression. So there are two ways that we are using the context compression. One is the offloading and other is the summarization. So offloading means if you are communicating with a lot of tools, then we know that the model, the agent will give a lot of information to the tool and tool will execute it and it will return back to the information there, and there will be like a lot of search criteria or search content will be there, right? So all those things keeping in memory is not a good thing. So what it does is we will put some kind of a threshold, like we can say that okay, 2000 token by default. If that is there, it will offload the data into the hard disk, maybe into a file. Okay, so that is what we mean by the offloading. And summarization is what happens in the summarization is if the context size is hit some threshold, like we can say that 85%, then the context is also summarized. So these are the two techniques that we are using for the context compression. Then another method that we use for the context control is like using the sub agents. Okay, so instead of the agents doing like agent does everything, what it does is all the complex tasks will be given to the sub agents. Okay, so sub agents will execute the information. Sub agent will execute the task and only the final result will be transferred back to the main agent. So main agent does not need to track like all the details. Okay, so it may be saying that okay, give me some information about like a agent or information about the deep agents, then it will go to the website, it will search that, and it will track all the details, and it will summarize the result, and it will give back to the agent. So agent only need to, the main agent only need to look into the summary. Okay, it is not need to remember like all the process that the sub agent has done. So in this way, we will able to reduce the context size of the main agents. Okay, now these are the some what we called some cycles of the sub agents. So ideally, the complex task will be delegated to sub agent, and sub agent will execute that. And we have explicitly, we have to say, once the task is completed, we have explicitly has to say to share only the final result back to the main agent. Okay, so that also has to, we have to explicitly say it, otherwise it will return all the raw content back to the main agent. So main agent also remember like these entire information from the sub agent, so that also we need to take care. Okay, so these are the some design rules that we have already discussed. Delegate complex and the multi-step tasks that require the high tool usage, that is assigned to the sub agent, and explicitly instruct the sub agent to return the synthesize the summaries. And the anti-pattern is, do not force the main agent to process intermediate tool calls, and do not allow sub agents to return the raw unfiltered data dumps back to the main thread. Okay. Now let's understand about the memory details. Okay, so in a agent or then a deep agent, we can see that there are usually three types of memories are there. We can say short-term memories are there, and working memory is there, and the long-term memory is there. Okay, so the short-term memories handles the active conversations, and the working memory handles the current task, and the long-term memory stores like persistent knowledge like user preference, project history, business rules, and the accumulated result, all those things that is included in the long-term memory. So I just want to pass on this also in this slide. Okay, and this is the high level unified deep agent architecture. So in a deep agents, we can see that there are 9 layers of the system prompt, like a user prompt, tool output, conversational data, contextual data, summaries data, all those things will be here. Then it is also like the compression details also there, compression protocol guard, the working for the memory boundary, that is also passed to the main agent core as a part of main agent core. Then we have a sub agent is there, then we have a long term memory is there. Okay, so I believe, I know that this is a lot of theory content is there, but the idea is to have a like a basic concept about the context engineering. I believe even though it is a little boring, lot of theories I know, but it is good to understand these details, because it will really help us when we do the real deep agent project. Okay, so I think that's it from my side. Please do like and subscribe. Have a nice day. Bye bye.